For today's lesson, we are going to learn how to prove properties of parallelograms using coordinate proofs. Coordinate proofs are different types of proofs than the two-column proofs that we did earlier in the school year. Some of you might like it a little bit better. Some of you might miss those two-column proofs. But I think that you guys are going to do very well in this lesson. It says day 6 and day 7, and that's because day 6 is talking about the properties of parallelograms, just parallelograms, and day 7 is proving properties of other parallelograms like rectangles, rhombuses, and squares. Our learning targets for today are for you to be able to say, I can write a coordinate proof using slope, midpoint, and distance formulas to prove the properties of all parallelograms. Before we get started with this lesson, you will need the following. First of all, you're going to need something to write with and some colors. Next, you will need a glue stick and all of our cutouts for the properties or for proving properties of parallelograms and using coordinate proofs. So all of your cutouts from day 6 and day 7. All right, let's go ahead and start off by defining a coordinate proof. So the word coordinate proof has a really awesome word in it, coordinate. So that means that we're going to be working with ordered pairs. And a coordinate proof involves placing figures in a coordinate plane. And using the slope, midpoint, and distance formulas to prove statements about a figure. To prove statements or properties about a figure. You can do a coordinate proof for any figure that we talk about in geometry, so it doesn't have to be just quadrilaterals. You can do a coordinate proof for triangles. You can do a coordinate proof for pentagons. It doesn't have to be a quadrilateral, but for our unit, we're just going to be focusing on special quadrilaterals. All right, so let's go ahead and start off by reminding ourselves of all of the properties of parallelograms. So these are all of the properties that we are going to be using. So I'm going to go ahead and paste this directly into my notebook. And I'm going to tell you all of the properties that we are going to be focusing on. So I know that there are a lot of properties of parallelograms, and we have already quizzed on these properties. But there's some that we are primarily going to be focusing on. So the first property of parallelograms is that opposite sides are parallel. I'm going to use the symbol for parallel. The second one is that opposite sides are congruent. The third one is that opposite angles are congruent, but not right angles. So I'm going to also write that down. They're not right angles in a parallelogram, only sometimes. And then we would just put that parallelogram into a different category. The fourth one is that the diagonals bisect the opposite angles, the diagonals bisect each other, And the fifth property that we are not going to be using in our proofs, but one that I want you guys to know is that consecutive interior angles are supplementary. But I put a star next to it because we are not going to be using this for proofs. Instead, we're just going to be working with the fact that opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, but not right angles. So that's the most important thing here, and that the diagonals bisect each other. Remember that properties of rectangles have all of the properties of parallelograms, but it has a couple of extras. Number one, the extra properties is that all angles are right angles. Which means that all sides, or the consecutive sides, are perpendicular to at least one other side. So those sides are going to be perpendicular. And number three, the diagonals are congruent. So I'm going to write that down. All angles are right angles. And all sides, therefore, are perpendicular to each other. So going all the way around, that's exactly what you will see, perpendicular sides that form right angles. And finally, the diagonals are congruent to each other. The properties of rhombuses are going to have all of the properties of parallelograms, but in addition, what you're going to find is that all sides will be congruent. The diagonals are perpendicular, so they intersect to form a right angle. And number three, the diagonals bisect the opposite angles, but I'm going to put a star next to this one because we are not going to be using that property in coordinate proofs. Instead, what you're going to find is that simply all sides are congruent, but what I need you guys to know about rhombuses is that the angles are not going to be right angles. So I want you guys just to be aware of that. When it comes to properties of squares are going to have all of the properties of parallelograms, properties of rectangles, and properties of rhombuses. But the main thing I want you guys to know about the properties of squares is that it has all angles are right angles. Which means that all angles are congruent. It also means that there will be perpendicular lines. Next, we're going to say all sides are congruent. And the third thing is that the diagonals are congruent to each other and perpendicular to each other. So those are the main things that I want you guys to know about squares. All right, I need to flip the page and we're going to hop into our next cutout. For coordinate proofs, what you're going to do is you're going to use the property, you're going to want to prove certain properties of parallelograms. So I'm going to go ahead and glue this in. And we can use the properties of slope, midpoint, and distance formulas to help us to prove a statement. Like if we wanted to prove that side lengths are congruent, what you're going to use is the distance formula. So So if you want to prove that side lengths are congruent, whenever you see the word congruent, that means we're going to look at the distance formula, and what we want to look for is we want to look for the same distance. We want to look for the same length, the same value. If we want to look at diagonals being congruent, once again, you see the word congruent. That means that we're going to be working with the distance formula. And once again, you're going to be looking for them to have the same distance, the same measure. If you want to show that opposite sides are parallel, parallel lines have the same slope. So we're going to be using the slope formula. And what we're going to look for is we're going to look for sides with the same slope. If we want to show that sides or diagonals are perpendicular, meaning that they have right angles, perpendicular lines form right angles, and they have opposite reciprocal slopes. So that means that we're going to be working with the slope formula. And what we want to look for is we want to look for sides with opposite reciprocal slopes. So let me give you an example of what opposite reciprocal looks like. An example would be like 4/3 compared to -3/4. So an opposite reciprocal means that you have a fraction that has been flipped and is the opposite sign. Opposite reciprocal, you flip the fraction, switch the sign. So this is something I want you guys to know. You flip the fraction, switch the sign. So I'm going to emphasize opposite means opposite sign. Reciprocal means you flip. You flip the fraction, switch the sign. And finally, if you see the word bisect, like diagonals bisect each other, that means that they have the same midpoint. So we're going to be working with the midpoint formula. And what you want to look for is you want to look for diagonals with the same midpoint. So deciding what formula you should use just depends on what is being asked of you. So what I have finally down here is an example of what a coordinate proof looks like. So let's go ahead and glue this in and do this coordinate proof. So an example would be they give you ordered pairs and they tell you that this is a quadrilateral. And so they want you to plot this quadrilateral. And I'm going to plot -2, -3, and then I'm going to plot and call it A, 4, -3. We're going to call it B, 3, 2. We're going to call it C, and -3, 2. And we'll call that D. Once you have these points plotted, you want to use a straight edge to connect these points. And then they're going to ask you to prove a statement about this quadrilateral. And what you're going to be asked to do in this problem is you're going to be asked to prove that both pairs of opposite sides are parallel. So that's what we want to do. Both pairs of opposite sides are parallel. So there's some key words. If you see the word parallel or perpendicular right angles, that means that you're going to have to use the slope formula. If you see the word congruent, you'll use distance formula. If you see the word bisect, you'll use midpoint. So maybe I should color coordinate it. The word congruent means you work with the distance formula. If you see the word parallel or perpendicular or right angles, you're going to use the slope formula. And finally, if you see the word bisect, that means that you're going to be working with the midpoint formula. So those are your key words here. And in this problem, we want to prove that both pairs of opposite sides are parallel. So the formula that we're going to use is the slope formula, which is m equals y2 minus y1 divided by x2 minus x1. You always have to write out the formula that you plan to use as a part of your proof. That is always step number one. How are you going to prove this statement? So now this question is asking you to show some math. So that means that we're going to need to identify our opposite sides and identify the slope of the opposite sides. So let's go ahead and start off with AB and DC and compare those slopes. So I'm going to find the slope of AB. So I'm going to write a little m and I'm going to write AB. And this is to remind me that I'm talking about the slope of segment AB. And we're going to use the ordered pairs that we have up here. So if it helps you guys to write the x1s, y1s, and the x2, y2s, that might be a good thing. So I'll make this x1, y1, and x2, y2 in pencil. And I'm going to write out that we have y2, which is -3, minus y1, which is -3. So minus negative, you have to be really careful with your signs, all over x2, which is 4, minus x1, which is -2. Negative, negative makes a positive, and I am left with 0 over 6. 0 over 6 is 0. Next, I want to find the slope of my opposite side, which is DC. And I'm going to label for DC x1, y1, and x2, y2. So y2 is 2 minus y1, which is 2, all over x2, which is -3, minus x1, which is -3, so minus +3. 2 minus 2 is 0, -3 minus 3 is -6, 0 over -6 is 0. Both of these opposite sides have the same slope. Let's look at the other pairs. So that's AD and BC. So I'm going to find the slope of AD. And I'm going to label x1, y1, x2, y2 this time. So D is already x2, y2, so I'll just make A x1, y1. So I'm going to write y2, which is 2, minus y1, which is -3. Be careful with your signs. All over x2, which is -3, minus x1, which is -2. Negative, negative makes a positive, so I am left with 2 plus 3, which is 5, over -3 plus 2, which is -1. So my slope is -5. Now I need to look at my final slope, which is CB. So I'm going to erase my x1, y1s, and I'm going to label x1, y1, x2, y2 for my B and C. So now I'm going to find the slope of BC. And we have 2, so y2 is 2, minus y1, which is -3. Be careful with your signs. All over x2, which is 3, minus x1, which is 4. Negative, negative makes a positive, and I end up with 5 over 3 minus 4, which is -1. 5 over -1 is -5. Both of these slopes are the same slope. So now I'm ready to write a conclusion. My conclusion is, since the slope of AB is equal to the slope of DC, and the slope of AD is equal to the slope of BC. So since this is what I found, that the slopes are the same, therefore, opposite sides are parallel. So if you notice that opposite sides have the same slope, equivalent slopes, we can therefore conclude that opposite sides are parallel. Or we would say both pairs of opposite sides are parallel, which is basically restating what we wanted to prove. And that is the end of today's lesson, as well as an example of coordinate proofs. If you have any questions over anything I just showed you, please feel free to email me. Otherwise, I hope you have a wonderful day.